Hello everyone, thanks for coming back to my YouTube channel. This video is for section 2.7 of my pre-calculus class, and that is for nonlinear inequalities. So I have this quadratic right here, x squared minus x minus 2, and I see the graph of it right here. And the first thing I know we all know how to do, at least hopefully by this point in pre-calculus, is we can factor this to two factors here of x minus 2 and x plus 1, and we know that we have zeros of 2 and negative 1. If we look at the graph right here, we can see right here we got negative 1 and we have 2. Now when we talk about nonlinear inequalities, now I don't have any inequalities with this one, but if I were to take x squared minus x and minus 2 and set that greater than 0, what that's essentially asking is, where is this parabola right here greater than 0? Now, greater than 0 means that where are we above the x-axis? And if we look at the picture right here, we can see that everywhere right here we are above the x-axis, and everywhere here we are above the x-axis. So if we were to talk interval-wise, reading left to right, this graph is above the x-axis from negative infinity up to negative 1, and from 2 to positive infinity. So that's where we'd be greater than 0. So obviously, or hopefully it's obvious to you, if we set this x squared minus x minus 2 less than 0, that means where are we below the x-axis? And we can see right here that here's the x-axis right here. We are below between negative 1 and 2. And that's where we're below the x-axis, or less than 0. So for the most part, it would be easy just to graph and look at it, and we would see where we're above or below. But we're going to take the analytic approach, and we're going to try to do this using some algebra to see where the graph is above or below the x-axis. So how do we do that algebraically? Well, we're going to do the same thing, kind of what we just did here. Now we can see that we have this quadratic, and the quadratic is set greater than or equal to 0. So again, what does that mean? That means where are we above the x-axis? Okay, so what we're going to do, and we're not going to cheat by looking ahead, but if you had to, if you're stuck, you look at the graph. We're going to factor this. So this is going to factor to x plus 4 and x minus 3. And we will see that the zeros from this are negative 4 and 3. Now, another word or another term you might hear is critical numbers. Negative 4 and 3 are critical numbers because that's where they could change from being above the x-axis to below the x-axis. So one of the things I like to do is I like to make a number line. So I make a number line, and I'm going to choose, and make sure I put them in order, that negative 4 and 3 are on the number line. And what I want to do is I want to pick test values. I want to use test values right here and see test values on this interval, on this interval, and on this interval, and see if they work. And that's how we're going to check to see where we're above or below, depending upon the inequality, the x-axis. Okay, so I'm going to pick a number that's to the left of negative 4 on this interval. So I'm going to pick something easy like negative 10. So I go to here and I put in negative 10. So I'm going to put in negative 10 right here and negative 10 right here. Now I don't necessarily care about the number. I just care about if it's positive or negative, because I'm looking for something greater than or equal to 0. And again, that's fancy talk for I want a positive number. So if I plug in a negative 10 right here, that's going to give me negative 10 plus 4, that's a negative number. Negative 10 minus 3, that's a negative number. Well, what's a negative times a negative? That's positive. So that actually works. So this interval works. Give me a number between negative 4 and 3. I'm going to pick 0. 0 is always a great number to pick. So I plug in 0 now. And so if I plug in 0, I get 4. That's positive. And I plug in 0 here, that's negative 3. So I got a positive times a negative, which is a negative, and that is not good. So that doesn't work for that solution interval. What about a number bigger than 3? Well, I'll pick something easy like 5. Plug in 5 right here. 5 plus 4, that's 9. That's a positive number. 5 minus 3, that's 2. That's a positive number. Positive times a positive, we get a positive. So this interval works. So now visually we can see which intervals work and which ones don't. And now we write our answer. The solution intervals are from negative infinity to negative 4 and from 3 to infinity. Now, you have to remember the basics here as well, that if you get a greater than or a less than, we're going to use parentheses. Greater than or equal to or less than or equal to, we're going to use brackets. Okay, so what do we have? We have a greater than or equal to. So that means we're going to include these. Now, the way we write it, in negative infinity and positive infinity, we'll always have parentheses. Okay, and then the numbers, the critical values, because we have a greater than or equal to, are going to have a bracket. So if we graph this, you will see that this quadratic or parabola is going to be above the x-axis on this interval from negative infinity to negative 4 and on this interval from 3 to infinity. Okay, let's do another one. Alright, this one's a rational equation. Okay, so there's some more algebra that's involved here, okay, to do this one. Alright, so first thing we got to do is we got to know that this is got to be a 0 here. So we have to move the 3 over to the other side. Alright, so I'm going to start with 2x minus 7 all over x minus 5. And I'm going to do minus 3. I'll leave some space here, and that's going to be less than 0. Now, the reason why I left some space is because I got to combine this 3 with the x minus 5. So what I'm going to do is I'm going to use the common denominator of x minus 5. So I'm going to multiply the top and bottom here by x minus 5, because that is my common denominator in order for me to put these fractions together. Okay, so now what I need to do is I got to make sure I distribute as well. So I got to distribute here. So when I do that, I'm going to get 2x minus 7. And then when I distribute, I'm going to have negative 3x, because I'm going to distribute the negative 3. And then positive 15. And this is all over my common denominator of x minus 5. That's got to be less than or equal to 0. Okay? Now, if I combine like terms, alright, so 2x and negative 3, that's negative x. Negative 7 and 15, that's positive 8. And then over x minus 5, less than or equal to 0. Okay. When you have a rational function, you're going to get critical numbers from the top and critical numbers from the bottom. So you're going to get zeros from the top. So you can set the top and bottom equal to 0. In this case, hopefully we should be able to do these in our head. The critical number from the top is going to be 8. And the critical number from the bottom is going to be 5. Alright, so again, I'm going to set up a number line. And I'm going to choose 5 and 8. And now I want to pick numbers on those intervals and test them in here. And now I want to see if I'm going to get a negative number. Okay, so a number less than 5, 0. So if I plug in 0, I'll get a positive 8 over a negative 5. Positive divided by negative is a negative. So actually this interval works. A number between 5 and 8 is, I'll pick 6. So if I put 6 in here, I'm going to get a positive number and a positive number. And that's not going to be good. I want a negative number, so that's not a good interval. And a number bigger than 8, I'll do 12. So a number bigger than 8, so I got negative 12 plus 8, that's going to be a negative. Positive on the bottom, so negative divided by positive, that's a negative, and that's what I want. So I actually have 2 solution intervals here for this one. Okay, now you got to be extremely careful with a rational equation now on parentheses versus brackets. Okay, so I know my interval is going to go from negative infinity to 5 and from 8 to infinity, and I know infinity is always going to have parentheses. Now, when you have a rational function, the top number, all right, the top one, we can use brackets because we are allowed to include it. The bottom one, we have to use parentheses because we're not allowed to include it because you're not allowed to have 0 on the bottom. Okay, so being very careful here, the critical number from the bottom was 5, so that one has to have a parenthesis. Critical number from the top was 8, and it's okay to be 0 in the top, so I'm allowed to include that. So that's using or having an example here with a rational inequality and how to solve that analytically, okay, or algebraically. All right, so let's try one last one. All right, I got x plus 6 over x plus 1 less than 2. All right, so again, what do you think the first thing we got to do is we got to move that 2 over. Okay, so if I move that 2 over, I'm going to have x plus 6 over x plus 1. Okay, and I'm going to have minus 2. Leave some space there because I got to get a common denominator. Less than 0. All right, so I know that my common denominator is x plus 1. That I'm going to have to multiply top and bottom by. All right, and I go back and I know I'm going to have x plus 6. I'm going to distribute negative 2x minus 2. And this is all over x plus 1 less than 0. So now less than 0, we're looking for a negative number. Okay, combine some like terms up here. I'm going to have negative x plus 4 over x plus 1 less than 0. All right, so now what are my critical numbers? My critical number from the top is going to be 4 because that's what makes that 0. My critical number from the bottom is going to be negative 1 because that's what makes that 0. Again, some side work. If you don't see it right away, you're taking negative x plus 4 and you're setting it equal to 0. So if you move the x over, you get x equaling 4. And then same thing on the bottom here, x plus 1 equals 0. You move the, you got x equals negative 1. So you're just seeing what the zeros are for the top and bottom. I'm going to make my number line again. Okay, and then I put my critical numbers on it. So once again, I want to make sure I put them in order. So I got negative 1, 4. So I got 2 critical numbers. I'm going to test 3 intervals. So a number that's smaller than negative 1. I'm going to try negative 3. So I put in negative 3. Okay. Opposite of negative 3 is 3. 3 plus 4 is 7. So I got a positive over a negative. Okay, so positive divided by negative is a negative, and that's what I want. I want a negative right here. So that works. What about negative 1 to 4? I'm going to pick 0. That's an easy one to pick. I'll get a positive divided by positive. That's no good. All right, what about a number bigger than 4? How about like 10? That's going to give me a negative divided by a positive, which is a negative. That's going to work. So I'm sure some of you are probably wondering, is it always going to alternate? No, it's not always going to alternate. It's just you have to do the test values to see where your solution intervals are going to be. Okay, so now I'm going to name my intervals. All right, so I know that my first interval is going from negative infinity to negative 1. I know I got parentheses there. And I'm going from 4 to infinity, and I got a parenthesis there. Now, I know the top is going to be brackets, and the bottom is going to be parentheses if my inequality is greater than or equal to. But I just have, all I have, though, is a less than sign. So I don't have to worry about brackets for this one. So everything is going to be parenthesis for this. So what is that saying? That's saying that I can pick any number from negative infinity to negative 1 and from 4 to infinity, and that will be a solution to my original expression. Okay, so hopefully that video helped you for section 2.7. If you have any comments or suggestions, go ahead and put those down below. And thanks for tuning in.